All right, welcome to the next addendum video. Now we're going to look at the section 16 addendum. And this addendum is fairly advanced because the test writers have actually added a lot of new questions to this section in 2018, and especially a lot of questions which deal with current and voltage levels in series and parallel circuits. So that's the main thing we're going to be focusing on today. Now, if that sounds confusing, I've simplified this with 4 simple acronyms, and these will help us to learn the concepts as we go along. Now, the first acronym I want to look at is PVS Kids. PVS Kids. So we're going to start looking at a parallel circuit. And you can see I've drawn a little parallel circuit. It has 2 resistors connected to a battery in parallel. Now, the rule here is that in parallel, for things in parallel, the voltage is the same. And what do I mean by that? So that means the voltage across 2 parallel components is the same as the voltage of the source or the battery. So if you look at this diagram I made here, you can see these 2 resistors. The voltage across these 2 resistors is the same as the voltage across this battery. So the voltage across these 2 resistors that I'm pointing at here is the same as the voltage of that battery. Those are the same. In parallel, voltage is the same as the source. The voltage across 2 parallel components is the same as the voltage as the source. In parallel, voltage is the same. And I made a little acronym for this called PVS Kids. And the PVS stands for parallel voltage same. Parallel voltage is the same. So if you were a kid once, which everyone was, then you may have grown up with PBS Kids. So you watched your cartoon, and at the end, the guy on the TV says, dun, 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 dun. PBS Kids. And I want to teach you a different jingle right now. Instead of saying PBS Kids, I want you to say dun 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 PBS ham radio. So that's how I want you to remember PVS Kids. Parallel voltage is the same. And there's another meaning to PVS Kids, and parallel voltage is the same. Another way to look at it is in parallel, the voltage is the same across all the components in the circuit. So in other words, the battery here has the same voltage as that resistor and the same voltage as that resistor. Everything has the same voltage. This has the same voltage as that. This has the same voltage of the whole circuit. The voltage is the same across all of the components in the circuit when we're talking about parallel circuits. So that's the first thing you need to know, PVS Kids. All right, now we're going to move on to another acronym and learn something else. And we're going to move over to series circuits now. You can see the series circuit I drew on the left. Now, in series, the voltage is additive for components connected in series. So, in other words, what that means is if the voltage of the battery is, say, 12 volts, or the voltage of the whole circuit is 12 volts, so in series, voltage is additive. If the series of if the voltage of the whole circuit is 12 volts, then the voltage of all the components, when you add them all together, will be 12 volts. So like say this is a 12 volt battery, and then you could say maybe there's 3 volts in this resistor and 9 volts in that resistor. It adds up to 12. In series voltage is additive. Something like that. We're just making up numbers here. That's not necessarily the case. But you get the idea that voltage is additive for components connected in series. And an acronym for this is Sally Vacuums Apartments. Again, the SVA stands for in series, voltage is additive. And that's how you can remember that. All right, the third acronym I want to go over is also in series. And the concept here is that in series, the current is the same. So just as in the parallel circuit, the voltage was the same for all the components, in a series circuit, the current is the same for all the components. So this resistor on the left over here has the same amount of current as the resistor on the top. And it has the same amount of current as the whole entire circuit. In series, current is the same. And an easy way to remember this is with the acronym the School of Computer Science. I'm heading into college now. I'm going to be studying computer science, which makes this easy to remember for me. I don't know if that's what you're going to study or not. Maybe it is. But anyway, this is one helpful acronym to help you remember. And if you think of other acronyms that work better for you, of course, you can replace those. So if we have 2 components in series, the current in component 1 is the same as the current in component 2. So if we go from, say, this resistor over to this resistor, the current doesn't change between those 2 components. The current at the junction is unchanged because the current is the same. And there might be a test question asking about that, which you'll study later. All right, and the last acronym we're going to look at is People Consume Donuts. And this acronym stands for in parallel current divides. So we're going back to parallel circuits now. In parallel current divides. So what this means is that in parallel, the current sort of branches off. One way to look at it is almost like the pipes aren't carrying electricity, but they're carrying water. So let's say they start over here and the water flows through the pipe up here. When it gets to here, it's going to split in half. Maybe say half of the water will go that way and half will go this way. It divides. It all divides up. So instead of, say, if the 1 amp was coming over here, if there was 1 amp coming along that way, you would now have maybe half an amp and half an amp going in those two junctions, in parallel current divides. And those 4 acronyms should cover you for all the new questions on the test. Now, if you look in the Gordon West manual, he actually has another method for explaining some of these questions, and that has to do with Kirchhoff's law, Kirchhoff's voltage rule, and Kirchhoff's current law. I didn't go over Kirchhoff's laws because I find them overly complicated. I learned them in advanced high school physics, and they're a little hard to explain, especially the way Gordon West, I feel like, explains it. I feel like this is a better way of understanding it, at least personally for me. If you think Kirchhoff's law might be more beneficial, or if you've taken advanced high school physics and you understand Kirchhoff's law, then by all means you can learn that way and go with whatever method works best for you. And that covers all the new stuff in the addendum.